Hi, this is Advanced Math, Chapter 12 on Vectors, Part F, Page 1. Vector equations in 3D lines. We've done planes in 3 dimensions, we've looked at vectors in 3 dimensions, and we solved some interesting problems with bird cages, but now we're going to look at something that is a little more challenging to do, which is how do you represent a straight line in 3 dimensions? One thing you could use a straight line in 3 dimensions for would be to model the motion of an object, like a bird moving in a straight line. And so that's kind of the approach we're going to take. So to do this, to explain this, what I want to do is work actually in 2 dimensions first, and then we'll try to extrapolate that to 3 dimensions. So I'm going to plot a line on this grid. Um, When you do this, you follow the instructions at the bottom of the grid. I would suggest that you avoid lines that pass through the origin. Um, Use lines that have a nice rational slope so that your line will pass through grid intersections at a regular interval, and that's convenient. Um, Good. So I've drawn a line here. Actually, literally use the straight edge on my tablet. And what I want to do is imagine that this represents, say, a bird moving through space or across a page. And we're going to track the location of the bird at different times. So we're going to start at t equals 0, and I'm going to just note the coordinates of the bird at that time. And bird's going to go over 3 and up to a new time, 1 second, say, and we've got coordinates there. And the bird's just going to keep following this pattern of moving over 3 and up really moving each second that goes by, the bird's moving the same distance along that line in the same direction. Over 3 up and then we get one there, t equals 5. There. Okay, so we've mapped out the position of this bird over a 5 second period at 1 second intervals, recording its position. And you could see with every second it's moving in the same direction, the same distance over and over again. And that's actually creating a straight line. Now you can imagine extending this to 3 dimensions. It would work exactly the same way, except our coordinate space would have 3 numbers instead of 2. All right. Now, to move forward, I just want to make a note of the equation that I used for this line. It has a slope, as you've noticed, of 2/3. So this is the equation y equals 2/3 x plus 2/3. I haven't gone through, like, how did I figure out that y-intercept? You could do that. Come on, it's just algebra. Okay, next up, we're going to do something weird with this.